Hello and welcome back to the tied up video demonstrations of basic physics concepts. In this video we discuss about Newton's first law of motion. Consider a cart at rest. It's very intuitive that this object will remain at rest unless someone gives a push or pull to this cart to change its state of rest. When we say that the cart is at rest, we assume that it is at rest with respect to a frame of reference fixed to the surface of Earth, which is considered to be an inertial frame of reference as we discussed in the previous video. Now imagine that someone is giving a push to the cart. As expected, the cart moves for a distance and eventually stops. The cart eventually stops because of opposing forces such as drag and friction acting on the cart, opposing its motion. Now, consider another thought experiment. Imagine that you are in outer space and pushing a spacecraft, just like you did previously. The push will provide motion to the aircraft and it will keep moving with a constant velocity forever, unless it is hit by some materials or fall in the gravity pull of some planet. Newton's first law says that every body continues a state of rest or uniform motion in a straight line, unless it is compelled to change that state by forces impressed upon it. The property or tendency of an object to remain in its state of rest or uniform motion along a straight line is called the inertia of the object. The property inertia is quantified by the mass of the object. Mathematically, we can say that if the net external force acting on an object is zero, then the object will remain either in a state of rest or at uniform motion in a straight line. That is called velocity is constant. Consider an example where an apple is resting on a cart at rest in which a frame of reference O' is attached. Since the weight of the apple is balanced by normal reaction, the net force acting on the apple is zero. Since the apple is subjected to no unbalanced forces, it will remain at its state of rest until it is acted upon by an unbalanced net force. Imagine another situation. An apple is rest on a cart moving with a constant velocity. In real life, this will only be possible when the cart is pulled with a constant force which is balanced by drag and frictional force at this velocity. And the weight of the apple is balanced by the normal reaction from the surface. The frame of reference O' is fixed on the table. Note that the apple is at rest with respect to a frame of reference O', which is fixed on the table, and it is moving with a constant velocity with respect to a frame of reference O. So now we can say that both the cart and the apple will remain in their state of rest or uniform motion along a straight line until some unbalanced force arises. We now realize that the state of rest or state of motion with a constant velocity are equivalent, which is suggested by Galileo Galilei even before Sir Isaac Newton rephrases this principle as first law. Now we consider the thought experiment we discussed in the previous video where an apple snapped from the roof of the stationary cart falls into a location A. The question was whether the apple will fall onto a point A if the cart is moving with a constant velocity 100 meters per second. The answer is yes, it will fall on A just like the previous case. The observer inside the moving cart see the motion of the apple same as seen by the observer in the stationary cart. However, an observer sitting outside will see the motion of falling apple differently. Now think about two questions. What will happen to the apple resting on the cart moving with the constant velocity when brakes applied? And for the previous examples, will the apple fall onto A if it is snapped when the cart is slowing down or brakes apply. We will discuss this in the next part 2 of the lecture. And thank you very much for listening.